In this video we'll be factoring special cases. In this case it will be the difference of two squares. So the name is important here because it tells us what we will be looking for. This special pattern will be the difference, meaning two terms will be subtracted and they'll both have perfect square roots. That's what that means. There are two of them. They'll have perfect square roots and we'll be taking the difference of the two. So perfect square roots, I think you know what that means, but let's get a list of everything, or at least many of them, that have perfect square roots. So all of these numbers here, I just put in y equals x squared in our calculator here. So all of the numbers in the y1 column have perfect square roots that are in the x column. So the square root of 25 is 5. The square root of 49 is 7. I think you know that already. I'm going to paste that in here because we'll be referencing it often. So when you are looking at these patterns, first thing you're going to see is, okay, I've got two terms. So far when we've been factoring, we've had four terms, which we grouped, and we had three terms for a trinomial, and we had various methods for that. Well, now if you see two terms, they're being subtracted and they each have a perfect square root, then you're going to use this difference of two squares pattern. And if you notice, 9n squared has a perfect square root of 3n. 100 has a perfect square root of 10. So let's go over that. The square root of 9 is 3. That's where this 3 comes from. The square root of n squared is n. And the square root of 100 is 10. So our pattern is this. You take your two sets of parentheses. You take these two perfect square roots. You add them in one parentheses and you subtract them in the other, and you're done. That's how that factors. 3n plus 10, 3n minus 10. It doesn't matter if you write the 3n minus 10 in this parentheses and the 3n plus 10 here. The order of the addition and subtraction doesn't matter. You just need to add them in one and subtract them in the other. So let's prove that this works out. So we're going to FOIL it out. So that would be 9n squared. That would be minus 30n. Use another color here. That would be plus 30n. And that would be plus 100, pardon me, minus 100. And if you notice, these middle terms actually cancel. Negative 30n plus 30n, those cancel, and you're only left with 9n squared minus 100. So you're back where you started. You know it's right. So again, we're looking for the difference of two squares. So we want to see a difference. It needs to be subtraction. It cannot be addition. It's got to be subtraction. It's the difference of two squares. We need two of them, two terms, and they need to both have perfect square roots. If they do, then you take the square root of each term, add them in one, subtract them in the other. So let's look at another example here. So the name is difference of two squares. So I see two terms. I see that we're taking the difference, and both of them have a perfect square root. Don't forget, one has a perfect square root. Square root of 1 is 1. The square root of n squared is n, so I'm going to take those, add them in one parentheses, subtract them in the other, and we're done. So that you see it, let's FOIL it out. So that would be 1, that would be subtract n, that would be a plus n, and that would be a subtract n squared. These two cancel, 1 minus n squared, check, and check. So your answer is this. These are your two factors, 1 plus n, 1 minus n. Square root of 1 is 1. Square root of n squared is n. Add them in one, subtract them in the other. Alright, last one for this video. So we are looking for this special difference of two squares pattern. And it doesn't matter if the a squared term is first or last. It doesn't matter. It'll still work. So we look at this. There are two of them. Check. We're taking the difference. Check. And when I look at these, they both have perfect square roots. The square root of 25 is 5. The square root of 16a squared is 4a. Okay, the square root of 16 is 4. The square root of 16 is a squared. Pardon me. The square root of a squared is a. So 4a altogether. So all I do, add them in one parentheses, subtract them in the other. And we're done. Okay, and just so you check, 5 times 5, 25. Check. 4a times 4a, 16a squared. Check. So we got the square roots right. You could FOIL it out and make sure. Let's put this one in our calculator and check. We haven't done that yet today. 25 subtract 16x squared is supposed to be the same as 5 plus 4x and 5 subtract 4x. Go in my table, second graph, make sure they all match, check, 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 y1, y2 are the same, so we know we did it right. Alright, that's it for this video. In the next video, we'll be doing the perfect square pattern.